competition and mathematical derivation of the equilibrium under perfect competition from the 5th module of mathematical economics. So what is perfect competition? Perfect competition is a market structure characterized by complete absence of rivalry among individual firms. What is rivalry? Rivalry means competition. So under perfect competition, there will be no competition among the individual firms. Certain other features of perfect competition that we already know are there will be large number of buyers and sellers, freedom of entry and exit, profit maximization, perfect mobility of factors of production and goods and services, perfect knowledge of the market condition, and there is homogeneous product, that is, which means that the products are identical. These are the other features of perfect competition. Next, we are going to the equilibrium under perfect competition. A firm is in equilibrium when it maximizes its profit. Profit is the difference between total revenue and total cost. Pi is equal to TR minus TC. This is the profit. So, profit is the difference between total revenue and total cost. When this difference between total revenue and total cost increases, the profit also increases. There is two other necessary conditions for the maximization of profit. Two necessary conditions for the profit maximization or equilibrium under perfect competition is MC is equal to MR and slope of MC is greater than slope of MR. Slope of MC is greater than slope of MR, which means that MC cut MR from below. If MC is less than MR, the total profit has not been maximized and the firm tries to expand its output. If MC is greater than MR, the level of profit is being reduced and the firm cuts its production. So, a firm is in equilibrium only when MC is equal to MR. Now we are moving on to the mathematical derivation of equilibrium under perfect competition. A firm is in equilibrium when it maximizes its profit. Profit is equal to R minus C. R is the total revenue and C is the total cost. Pi is the profit. So, the first order condition for the maximization of a profit is that the first derivative or the first order derivative of the function must be equal to 0. So, this is our function. The first order derivative of this function is dou pi by dou x is equal to dou r by dou x minus dou c by dou x, which should be equal to 0. So, which means that when we subtract dou c by dou x from dou r by dou x, we get 0, which means that dou r by dou x is equal to dou c by dou x. Dou r by dou x is the slope of the total revenue function, that is marginal revenue, and dou c by dou x is the slope of the marginal cost, is the slope of the total cost function, that is marginal cost. So our first condition is satisfied here, that is MR is equal to MC. The second order condition for the maximization is that the second order derivative of the function must be negative. So pi is equal to R minus C. The second order derivative of this function is dou square pi by dou x square is equal to dou square r by dou x square minus dou square c by dou x square. So, dou square r by dou x square minus dou square c by dou x square must be less than 0, which means that the second order derivative of this function must be negative. From this we get that dou square r by dou x square is less than dou square c by dou x square. So, dou square r by dou x square is the slope of the marginal revenue and dou square c by dou x square is the slope of the marginal cost. So, our second condition is also satisfied here. We can see that the slope of MR is less than slope of MC, which can be also read as the slope of MC is greater than slope of MR. Our second condition is also satisfied here. This is the mathematical derivation of the equilibrium under perfect competition. Slope of MC is greater than slope of MR, which means that MC has a steeper slope. So, this is the equilibrium under perfect competition, and x-axis we have quantity and y-axis we have price, and this is the price line. Under perfect competition, MR is equal to P. This is only under perfect competition, MR is equal to P, that is marginal revenue is equal to price. So this is the marginal cost. This is the marginal cost curve, and E is the equilibrium point where MC cut MR at point E, and MC cut MR from below, that is slope of MC is greater than slope of MR, and this MR is equal to AR. This is the equilibrium level of quantity, and this is the equilibrium level of price. Now we are going to do an example. This is the question. Given P is equal to 100 minus 2x and C is equal to 50 plus 40x, find the equilibrium of the firm and whether the profits are maximized. So the price function and the total cost function is given. We have to find the profit and whether this we have to find the maximum level of profit and or the equilibrium level of profit, and whether this profit is maximized or not. Okay, now we are going to solve the problem, and the goal of the firm is to maximize the profit. Profit is equal to R minus C, total revenue minus total cost. So we have to find the equilibrium level of profit and whether the profits are maximized or not. So first we have to find the total revenue. Total revenue is equal to X into P. X is the output and P is the price. So price is already given in the question, that is 100 minus 2x. So total revenue is equal to X. X is the output. X into this price function, that is 100 minus 2x. R is equal to X into 100 minus 2x, which gives 100x minus 2x square. So the total revenue function is 100x minus 2x square. From this we have to find the marginal revenue. Marginal revenue is the first order derivative of the total revenue function. So we have this, when we differentiate this 100x minus 2x square, we get the marginal revenue. So marginal revenue is equal to 100 minus 4x. Next we have to find the total cost is already given in the question, and we have to find the total cost and the marginal cost. So our total cost function is 50 plus 40x, which is already given in the question. So we need to find the marginal cost out of this. So marginal cost is the first order derivative of the total cost function. The MC is equal to dou C by dou x. Dou C by dou x. So we get, when we differentiate this function, we get 40. Now we need to equate MR is equal to MR and MC. So MR we already find that 100 minus 4x. MR is equal to 100 minus 4x, and MC is here 40. We need to equate this. So 100 minus 4x is equal to 40, and 100 will go to this side. Minus 4x is equal to 40 minus 100. So minus 4x is equal to minus 60. So x is equal to, this minus will go here, and x is equal to minus 60 by minus 4. So x is equal, the output is equal to 50. So we find the x here, x is equal to 50. Now we need to substitute the value of this x into different function to find the equilibrium level of profit. So we substitute the value of x in the demand and price function, that is P is equal to 100 minus 2x, which is given in the question. We find that x is equal to 50. So P is equal to 100 minus 2 into 50, which is equal to 100 minus 30. So price is equal to 70. Now we are going to find the profit. Profit is equal to R minus C. R is equal to 100 minus 2x square, that we find. And so 100 minus, so we substitute the value of x here, and 100 into 15 minus 2 into 15 square, which is equal to 1500 minus 450, which is equal to 1050. This is the value, this is the total revenue. So total revenue is equal to 1050. Next we are going to find the total cost. Okay, this is the total cost function which is given in the question. Total cost is equal to 50 plus 40x. Now we substitute the value of x into this function. The x is equal to 15. So 50 plus 40 into 50, which is equal to 50 plus 600. So total cost function is equal to 650. Now we have to find the profit. Profit is equal to R minus C. Profit is equal to R minus C, and profit is the difference between total revenue and total cost. Total revenue, we already find that total revenue is equal to 1050. So profit is equal to pi is equal to 1050 minus 650. 650 is the this total cost. Total cost is equal to 650. So 1050 minus 650, we get 400. This is the equilibrium level of profit. Next, we have to find whether this profit is maximized or not. There are two conditions for the maximization. The first condition is that the first order derivative of the function must be equal to 0, and the second condition is that the second order derivative of the function must be negative or less than 0. So here total cost is 50 minus 50 plus 40x, and the first order derivative of this total cost function is mc is equal to dou c by dou x is equal to 40. The second order derivative of this function is equal to 0 because 40 is a constant. Next, we move on to the total revenue function. Total revenue function is equal to 100x minus 2x square, and marginal revenue, that is the first order derivative of the total revenue function, is equal to dou r by dou x, which is equal to 100 minus 40x. When we differentiate this function, we get 100 minus 4x. So the second order derivative of this total revenue function is equal to dou square r by dou x square, which is equal to minus 4. When we differentiate this marginal revenue, we get minus 4, which is less than 0, which is a negative value. So we can say that the profits are maximized. Hence, this is a negative value. The second order derivative is a negative value. We can find that the profits are maximized. When we subtract this total cost, that is the second order derivative of the total cost function, that is 0, from this second order derivative of the total revenue function, that is minus 4. Minus 4 minus 0 is equal to minus 4 itself. So we can see that the profits are maximized. So that's all. Hope you all understand. Thank you.